Good morning to all. Today we can discuss about the Zener diode and its operation and its characteristics in the subject electron devices and circuits. Zener diode is nothing but one of the most important semiconductor diodes, which is a specific diode that works in reverse bias conditions. So this reverse bias it is operating in a reverse biased region. A Zener diode is a highly doped semiconductor device specifically designed to function in the reverse direction. So they are special semiconductor devices that allow the current to flow in both forward and backward direction. It is also given the name breakdown diode because of the operation in the reverse bias condition. This is the symbol which represents the anode and cathode. So this is the way it will be looking like practically designed with the terminal anode, and the cathode will be having a silver line in the opposite. So how it is going to work? So normally it will be acting as normally it will be acting as a forward bias PN junction diode in forward bias condition. In no biasing condition of the Zener diode, all the electrons accumulate in the valence band of the p-type semiconductor material, and thus no current flow occurs through the diode. So this particular it will be operating only in the reverse bias condition. So as we increasing the reverse voltage, it reaches a point where the voltage equals the breakdown voltage. So the breakdown voltage is represented as VZ, and this condition the current starts flowing the diode. So after the breakdown voltage, the current increases drastically. It reaches the stable value. So in reverse bias condition, if the Zener voltage is equal to the supplied voltage, the diode conducts electricity in the direction of reverse bias. Normally in the PN junction diode, you have the reverse current will be normally zero. So this particular is due to, and it gets breakdown due to avalanche breakdown. But this Zener diode will have both this avalanche breakdown as well as the Zener breakdown, because while seeing the characteristics, you can see this. So in the avalanche breakdown happens at the cut-in voltage, and the Zener breakdown happens in the another one voltage that is called the Zener voltage. So what there are two things. One is avalanche breakdown, and another one is Zener breakdown. So what is avalanche breakdown? So the when the p-n junction diode is reverse bias, the thermally generated minority carriers constitute the flow of reverse saturation current through the diode. These carriers acquire energy from the applied potential and collide with the crystal ions present in the particular material. So as a result, the bonds get covalent bonds are disturbed, and a new electron hole pairs are generated. This in turn increases the energy and occurs high velocity, and these high velocity electrons will collide continuously for providing a current. That current increases rapidly in the diode. So as a result, it will be reaching a higher value of current, and this phenomenon of sudden increase in the current is called the avalanche breakdown. So this phenomenon damages the diode permanently, whereas the Zener diode is a specific diode that is made to operate in the reverse voltage area. So if the reverse voltage is greater than 6 volt, the avalanche breakdown happens in the Zener diode. Otherwise, it does not happen. Zener diode, it happens in a heavily doped PN junction diode. The width of the depletion region becomes very small. As a result, what happens? A small voltage around 5 volt can produce high electric field intensity within this narrow depletion region. Under the influence of this high electric field, it gets stronger, and it's sufficient enough to pull electrons from the valence band. These electrons then gain energy from the electric field and break free from the atom. So this new electron hole pairs thus created increase the reverse saturation current. A slight increase the voltage causes a sudden increase in the current. So approximately the electric field is 2 into 10 power 7 volt per meter. For heavily doped diodes, this value is around 5 volt. Hence, for heavily doped, Zener breakdown is the predominant effect. For lightly doped diodes, the breakdown, which is the avalanche multiplication, is predominant, and for Zener, it is predominant. So by seeing the characteristics, we can say that See this, the forward characteristics, it is normally same as your normal PN junction diode, but in the reverse bias condition, the reverse voltage condition, a small amount of current flows through the Zener diode. This current is because of the electrons which are thermally generated in the Zener diode. But when increasing the reverse voltage at a particular value, it's great around 5 volt. Avalanche breakdown happens after 6 volts. Here it between 5 to the less than some 6 volts. Okay. So at any particular value of reverse voltage, the reverse current increases suddenly at the breakdown point. This voltage is called Zener voltage, which will be making the particular increase in the current suddenly. This is about the Zener diode and its characteristics. Thank you.